The next parametric test that we will consider is the ANOVA, or the one-way analysis of variance. This test is used when you want to determine whether there are significant differences between the sample means obtained by 3 or more groups. For example, we can use a one-way ANOVA to determine whether scores obtained on an English grammar test differed as a result of 3 different types of instruction that learners received. This would mean that you have a research design where you divided your participants into 3 independent groups. For example, an explicit grammar instruction group, an implicit grammar instruction group, and a no grammar instruction whatsoever group. An ANOVA can tell you whether one of these types of instruction significantly affected performance in English grammar. An ANOVA compares the variance, which is the variability in scores, between different groups with the variance within each of the groups. An F ratio is calculated by dividing the variance between the groups by the variance within the groups. A large F ratio suggests that there is more variability between groups than within groups. A significant F test provides grounds for rejecting the null hypothesis that groups are the same. The ANOVA is an omnibus test, which means that it doesn't specify exactly where a group difference occurred. It merely determines that there is a difference. So we know that at least 2 of the tested parameters are statistically different. In order to determine exactly how the groups differed from each other, you will have to include a post-test in the analysis. The Tukey test, or the Bonferroni test, is commonly used as a post-test in the ANOVA analysis. There are many different types of ANOVA models, including ANCOVAs, repeated measures ANOVAs, and MANOVAs. ANCOVAs allow you to control for the effect that a covariate might have on the dependent variable. Repeated measures ANOVAs allow you to assess differences in group means over a period of time, and MANOVAs allow you to assess multiple variables simultaneously. Analysis of variance methods can be univariate or multivariate. In a univariate analysis, we are interested in the effect of one independent variable on one dependent variable. In a multivariate analysis, we want to consider the effect of one or more independent variables on a whole set of dependent variables. To build on our earlier example, if we wanted to test whether there are group differences in our 3 grammar instruction groups in English grammar performance and in English comprehension and in English writing, we would have to do a MANOVA, as we now have 3 different dependent variables. To read more about the underlying assumptions of ANOVA and MANOVA tests, you can click on this link. This slide provides an example of the output that is generated by SPSS when you run an ANOVA. The dependent variable in this study was criminal thinking, and the independent variable is age. 3 different age groups were included. As with the t-test, the software will generate all your descriptive statistics, and it will also conduct all the assumption tests that you have selected, for example, Levine's test. The ANOVA table provides the F statistic, and as can be seen, there was a significant effect of age on criminal thinking. The multiple comparisons table provides the results of the Tukey post-test. Here we can see that there was a significant difference between age group 1 and age group 2, as well as between age group 1 and age group 3. There was no significant difference between age group 2 and age group 3. To determine which group scored higher in criminal thinking, you have to return to your descriptives table.